Hey everyone, I'm glad to see you here. Thank you for joining the talk. And in the next 35-40 minutes, we will be talking about infrastructure as code for JavaScript application on AWS with TypeScript. And my promise for you is that till the end of this talk, you're going to have complete infrastructure production ready one for your front-end application. So if you're ready, let's crack on. Before we continue, let me introduce myself. My name is Denis Artyuhovich. I'm from Belarus originally, now based in London. I'm team lead at DAZN. And at DAZN, we're changing every aspect how fans are engaging with sports, starting from the content distribution and truly immersive experience for live matches and vote content. We are available on various type of devices, including smart TVs, mobiles and tablets, laptops, game consoles such as PS5 or Xbox, whatever. And I think you can imagine how many types of various infrastructure we have. So why do we need infrastructure as code? I think the answer is obvious, but nowadays it's increasingly crucial to automate literally everything what can be automated, right? And yeah, let's consider just normal feature development flow. We're starting with one idea, implementing one feature, then the other shiny idea comes to stage and we have two features, and then boom, hundreds of them. And that's actually exactly our case. We have hundreds of, probably thousands of different features, and we can expect changes in our infrastructure even multiple times per day. So I think you can imagine how stressed it could be. What if you're going to do it manually? What if someone forget to document specific checkboxes? Or what if UI on our cloud provider, let's say AWS, has changed and we click on the wrong tick box and yeah, our site not available anymore? Oh, that can be stressing. Just to avoid such situation, we need to take advantage of the infrastructure as code. And before we continue, let's consider these two programming paradigms because they are quite relevant when we're talking about coding for our infrastructure. So imperative one stands for explicit instructions, which actually the biggest advantage of the approach. You basically specifying all your instructions, usually in some bash scripts, and you kind of have full control, full flexibility. But at the same time, it's the biggest concern because you need to maintain everything yourself, and likely it won't gonna scale well. With a declarative approach, instead of specifying everything step by step, you're just describing the outcome of this, like a shape of your state which you expect to be applied. And yeah, it's usually way simpler, scales better, if someone has implemented this declarative approach, if someone has implemented those providers which allow you to work in a declarative way. So just to recap, imperative stands for explicit instructions. When if something goes wrong, you likely gonna blame system because you wrote so many code. You're a truly amazing developer, but it doesn't work as expected. But with a declarative approach, you rely on providers which are doing the job for you, and yeah, you don't really care what happens under the hood. So, and the good news that Terraform, which is open source infrastructure as code software tool, originally developed by HashiCorp, provide us option to write our infrastructure as code in a declarative approach. And what's even more important today, it supports TypeScript and more than 1,000 providers. So, or better to say that CDK, which is Cloud Development Kit, developed by AWS, supports TypeScript. And in the next 30 minutes or so, we're gonna build production-ready infrastructure for our front-end application. I will be using React as a boilerplate for the application itself, but you can use whatever you prefer. If you want to do it on Vue framework or Angular, whatever, any framework you choose, it's going to work for any JavaScript application. So yeah, I think we can start. And to start with, we're going to generate the project, and it's actually only one time when we're going to touch the React itself. So I'm going to use React Create App. to generate the basic project. I call it IAC demo project. I'm passing the template, which is TypeScript. And after command is executed and finished, we should be able to see this familiar for many of us website. If you done it, we ready to start creating our infrastructures. We have like prepared project. So as a pre-requirement, we need to install CDK-CF CLI, and you can install it globally on your laptop, or you can have it per project. It's up to you. So once we have it, we can run CDK-TF to generate the Terraform boilerplate. But before, we need to create the Terraform folder where we're gonna do all this magic. So we're running CDK-TF init and passing template TypeScript similarly as what we have done with the React Create app. And yeah, it asks us for the project name. We take the Terraform, the default name of our folder, and it starts execution. After this, you're gonna see some failures. No worries, it's just because the Terraform CLI probably not expecting that there will be other TypeScript project in the same place, but it's really easy to fix. They are related to our React project, those errors. So we just need to fix our tsconfig and add skip lib check with the flag true, and after that, everything will be okay. So I'm passing skip lib check true, and after that, you're gonna see that we have, so now we have Terraform folder and we have main.ts file. This main.ts file we will be modifying and writing infrastructure in. As you can see, just a class which is extended from the Terraform stack. And yeah, as I said, everything what we're gonna do here in this file, but later you can create, let's say, source folder and any subfolders and structure in the way you prefer your infrastructure. Because you have a TypeScript, and yeah, literally everything is possible. So now let's add the provider. As I said, we're going to use AWS as a cloud provider, so we need to modify our CDKTF JSON file and add the provider here. I'm going to use AWS one. There are no other providers required at the moment, and we ready to start. So now let's think about how our infrastructure gonna look like. What we actually need from it. We definitely need to store our static file somewhere, right? So and for this purpose, we're gonna use S3, which stands for Simple Storage Service provided by AWS. It has great availability, I think about 99.99% scalability and all this stuff. But yeah, what's important for us, it allows us to store files and get access to them. It even supports some domains. So let's gonna try it, and let's gonna create code for it. So we're gonna import AWS provider and S3 bucket provider from generated providers, which are available for us because in the previous slide we have added them to the list of providers. I'm gonna use bucket name as my domain name because we're building the real infrastructure. So I think it makes sense. You can use as many providers as you like in your configurations. You can use any regions you prefer for your S3 bucket, but just keep in mind that as later on we will be using the provider for ACM. To issue SSL certificate, AWS requires US East 1 provider. So if you're going to use a different region for your provider for S3 bucket, don't forget to create other one for ACM, but we will cover it a bit later. Okay, so with the S3 bucket, everything quite straightforward. We're just passing our bucket name, we specifying access control list as public read because who cares about security, right? Sorry, I'm making fun. Of course, we're gonna fix this a bit later. We're specifying that our S3 bucket will be the website, and we're gonna have index HTML as index document. After this, what we need to do, we need to run yarn build, synthesize our code, go to the CDKTF out folder, and run following commands. So we start with init. This is one-time command because we just starting. We need to run it. Later on, we can continue only with plan and apply. Plan, it's not the same as validation, but it just shows you what will be planned to apply with your infrastructure, what state you plan for the next apply. And apply is basically command to apply your changes, okay? So if you run them, you're gonna see such output in your terminal saying you that website endpoint will be this domain. And actually now what we can do, we can try to build our project. This is a React project, so we go out from the Terraform folder back to our application folder, and we're gonna copy everything to our S3 bucket. And with the deployment state, I would like to highlight a few bits. Actually, deployment can be done with the infrastructure together. Terraform can handle it, but in this particular case, I think it's a bit pointless because you can expect deployments, I don't know, in a more frequent manner, and usually you're gonna have either some CI integration for your deployments, separate one, or probably even some deployment dashboard. It depends on your preferences. So usually those things are separated, and we're gonna keep them separated here too. So we will be use just command line instruction and going to use AWS CLI. So you need to have pre-installed AWS CLI to execute this command. But yeah, basically we just saying AWS S3 sync, passing the build folder which we would like to put to the S3 bucket, and specifying our S3 bucket name, which you just have created. We're also passing the access control list as public read, same as we done it previously. But as I said, we're gonna cover it a bit later. So if we run it, now we can go to the bucket name.s3.aws.com index.html and see that our website is available. And let me congratulate you, because that's a great achievement. We just implemented probably simplest possible, but our own infrastructure with code for the front-end application. But to make it more production ready, we need to connect it with the real domain name, right? So for this, we're going to use Route53, which is domain name system service provider by AWS, DNS in short. And yeah, let's have a look on our user flow in this case. So basically, users, they're gonna write www whatever our domain is. They will be later transferred to the AWS private infrastructure, which is gonna alias our call to the Route53, and Route53 will be aliasing our users to the S3 bucket. Okay. So now, as we know what we're gonna do, we can build it. For this, we're gonna import Route53 zone and Route53 record, and gonna create initially hosted zone, for which we need just pass the provider and the domain host. This is domain host, because I'm gonna create our domain on actually to be a subdomain of the main domain. So if it makes sense for you. And we're gonna use a record. So again, we creating Route53 record, passing our domain name, and specifying the behavior that it's gonna alias our user to the bucket. Okay. We run again yarn build, yarn scenes from the Terraform folder, go to the cdktf out, run plan and apply, and yeah, our state will be applied. But during this execution, this time, you will see that apply step gonna fail on the very last part. And the reason for this, I did it intentionally. Sorry, let me probably show it a bit more. Yeah, so it fails, and fails on the validation step. And the reason for this, because intentionally I bought domain not on AWS itself. I bought it from the different domain provider, which is, I think, quite common case. And you need to remember that you need to meet them somehow, right, together. So let's have a look what we have created on AWS, and I think it's gonna be clear. So we go to the Route 53, we see that hosted zone actually already created. And in this hosted zone, we're going to see that there are even records created. There will be 2 default records and 1 A record. So as soon as, yeah, you see NS and SO records, they are created by default, and A record is what we have created. So now from the NS record, we need to copy NS values and add them to our domain provider. If you use quite popular domain provider and have provider for this in Terraform, you can even handle it with Terraform, but it is one-time instruction, so we can even do it manually, like what I'm gonna do, because my domain provider is Russian one and it's not very popular. They don't have any IP integration. I don't think they even support updates with I don't know, REST API or something. I really think they not. But yeah, so I'm gonna do it manually. I'm just adding my NS server there. I'm pressing save, and I need to wait 5-10 minutes till NS servers will be updated. And as soon as they are updated, we're gonna run. We're ready to run Terraform apply again. There is no need to run any other commands as we haven't done any changes, so there's no reasons to build it again or something. So we're running apply again. Yeah, it's asking, do we want to add these changes? But this time, you're gonna see that it's gonna be completed successfully. So it means now we can open our domain and see that our website available here. Woohoo! But still, right? To make it production ready, we need a few things. I might think that we need at least SSL certificate to make it secure here. And I think we need to make it more performant, right? Because currently we have created our website and put it to the S3 bucket, which is available only in United States. And because we used US East Region 1. And you can imagine that round trip won't be so fast as we may expect to be to edge locations, right? So we can need to take advantage of CDNs and distribute our code to across different edge locations, so our users can have best performance possible to fetch our website. So let's try to implement it. For this, we're going to use, oh yeah, let's deliver previous one. For this, we're going to use CloudFront and AWS Certificate Manager, where CloudFront is CDN provider. So CDN stands for Content Delivery Network, and a Certificate Manager will be responsible to provide to issue SSL certificate, which we will assign to the CloudFront. Cool. Let's have a look on our infrastructure diagram one more time. Again, we have Route 53, we have CloudFront, but now, so Route 53, instead of addressing directly to the S3, will be redirecting to closed edge location available with CloudFront. And CloudFront itself will be responsible to retrieve object for caching during caching validation or for the very first requests. So it's also going to have a certificate issued by ICM. And to create it, let's start with a certificate. We gonna create certificate with ACM certificate provider. We specifying a wildcard here because I'd like to issue the certificate for all subdomains. I'm creating validation record, and after this, I'm creating the validation itself, passing the record and passing the certificate. Once it's ready, we can create CloudFront distribution and assign it. So with the CloudFront distribution, we just specifying the origin, passing our bucket and the domain name. After this, we're gonna specify default root object and saying that there is no any restrictions yet. You can later assign any restrictions you may have. For example, if you'd like to disable certain countries because of, I don't know, maybe you don't have rights to launch on them or something, whatever your call. And we're going to specify default cache behavior, which is going to be for get, head, and options methods only, because we don't really need to have it for post or something, as it's only as it is as this infrastructure for the front end only. We're going to redirect everyone to HTTPS, as we have now issued certificate. Why not to use it? We're specifying the default ETL as a 1 day in seconds, and we're not specifying order cache behavior yet. And actually, order cache behavior is responsible for override. So for example, you can have default cache behavior for everything, let's say to be cached for 1 day, but specific folder you want to be cached only for 1 minute, or let's say forever. You can list it in order cache behavior. You also can say that index.html shouldn't be cached at all. And yeah, that's also possible. Yeah, we are assigning viewer certificate, our ACM certificate, and we're going to change route 53. Instead of aliasing to the S3 bucket like previously, now it's going to be alias to users to the CloudFront distribution. So we specify CloudFront distribution name and hosted zone ID. As soon as we're ready, we can again run build, scenes, and Terraform plan and apply. And magic happens. Everything should pass successfully, and you should be able to open the website. And this time you're going to see that it is secure. And moreover, it wasn't fetched from the United. Okay, for very first call, probably it still was fetched from the United States S3 bucket, but in general, it's now fetched from the CloudFront. So it's way more performant. Yeah, it's distributed across all edge location AWS supports, and yeah, that's awesome. And now I think it's a time just to cover the security part, because we skipped at the beginning of the talk, right? So we'll use one more thing, which is called origin access identity. So let me show you a diagram to help you understand how exactly it's going to work. So as you can see, not many things changed, but now CloudFront gonna retrieve objects for caching from the S3 as previously, but this time S3 bucket gonna have some bucket policies which will be allowing access to anyone who tries to perform some operations on the S3 bucket. To only those who have origin access identity. It means CloudFront should have origin access identity, specific one, which will be listed in bucket policies to have access to it, okay? So our S3 bucket no longer will be publicly available, and yeah, it's gonna be our complete infrastructure. So to achieve that, what we need to do, we need to create origin access identity here. We need to create policy document. Again, sorry, one note, probably worth to mention it earlier, but please don't be scared if you see some configuration which you don't really understand, because they sometimes not really related to the infrastructure as code as a thing. They sometimes related to the cloud provider. In our case, there are quite a few things which are related to the AWS itself, and if you haven't worked with it, you probably just don't know in which format they want configuration to be passed in. But it's quite easy to get it from looking to their docs. Plus, for each provider which supported by Terraform, on the Terraform website, you can find rich documentation which help you to understand everything. Sorry. So we're creating the policy document. We're specifying that we want to have access to objects. We're specifying that we want to have access to list of objects. So, and after this, we creating the S3 bucket policy, assigning the bucket itself and the policy itself. I think it is straightforward after we had a look to the diagram. And yeah, we're adding these changes to our IAC certificate to have this origin access identity. Okay, so it will be available for the CloudFront. Now, what we can do, simplest option, just remove everything what we have previously deployed to the S3 bucket and redeploy it again, this time not specifying ICL at all, so it will be use default one, private one. And if you've done it, we can try to open the S3 domain again and see that we have this nice access denied page provided by AWS for us. And when with a CloudFront and Route 53 with a regional domain, normal one, everything is okay. So site still operatable, so all good. So if you're now sweating as I am, take a deep breath. We very close to the end of this talk. We're not gonna write infrastructure more during this talk at least, but there are a few bits which I'd like to cover with you. And first one is remote backend. If you remember at the beginning of the talk, when we initialized the project, we started with a local backend, and I said that yeah, if you know what backends in Terraform world means, that's great. If not, we're gonna cover it, and it's time to cover it, because when you work alone, in theory, yeah, you can handle everything and store it on your local machine. But if you work at least with some other dev or in a team, you need to store your state of the Terraform somewhere, right? You probably may think as the first thing about GitHub, but it's not the best idea because it's certainly going to have some sensitive information, and Terraform provides better options for this, and it calls backends. So it supports various databases, including DynamoDB. It supports S3 bucket. They have even their own cloud storage for this. So as we started with AWS, let's stick with this, and let's put our backend on AWS. So let's create the S3 backend. For this, we actually need just 3 parameters. We need to specify bucket name. It shouldn't be the same bucket name as we stored for our application. It's like completely separate thing. So it can be like completely private, manually created, or created with a different Terraform project. We specify key, which is just our name for the file. Yeah, I just specified infrastructure is called talk demo project. And again, we specify ingredient, which can be any. After we're done with this, we need to go, we need to build scenes, of course, and go to the Terraform cdktf out folder. And here we need to run Terraform init again. This command, if you remember, we have run at the beginning of the talk. We need to run it again, and this time it's going to ask us, do we want to copy existing state to the new backend? And if answer is yes, local version will be removed, and on our S3 bucket there will be this deployed version. So in this file, it's actually just a JSON with a state describing our current infrastructure. So now, why TypeScript? Why we need to use TypeScript to coding for our infrastructure? So I think it's important that there is no new language to learn, because with Terraform previously, you need to learn HashiCorp configuration language, which is not that bad. I mean, it's even not complex at all. It's slightly more complex than YAML or JSON, which are not configuration languages, but this one has some loops. But we are developers, right? And I'm coding for many years. I really like the power of programming languages, and that's certainly what I like create my infrastructure in, and get all advantages it shares with me, such as powerful autocomplete and typings, because now it's even way easier to understand what exactly I need to specify to certain providers, because previously I was always needed to visit the Terraform website to check the documentation. Now I can check just typings, and if there sometimes there are even comments, and yeah, that's great. It speed up the development. Plus, we have all mature language advantages. We have, I don't know, like with array, all those methods like maps, reduce, whatever. We have options for code structuring because we have modules. That's something you don't expect from the HashiCorp configuration language. With this, you just store everything in a single folder, and you don't know what depends on what. When with a TypeScript, you have modules when you can import certain bits, you can share certain bits, you can create functions, which accepting some parameters and then mixing your state, whatever. Do any magic you want. There are way more features available now for you. And we have new ways of sharing, because previously there were options to share complete models through Terraform ecosystem. Now we have completely new ecosystem when we're talking about JavaScript, and I mean NPM. So we can partially or fully share our infrastructure with reusable functions, classes, whatever. We can implement tests for our infrastructure on the same language, on the TypeScript. So I think now it's way like it's a big step closer to developers. And yeah, that's one of the reasons why I'm doing this talk for, especially for front-end developers, because I found that, of course, DevOps and back-end developers, they know what infrastructure as code. Usually, they know what infrastructure as code is and why it's needed. When for many front-end engineers, I found that it is still buzzword, and I want to change it because it's very important not only to create the infrastructure for the website like we just did during this talk, but create infrastructure for monitoring and alerting. Let's say we want to specify some specific conditions to alert with a new relic, or maybe we want to specify them with Sentry, I don't know. Maybe we want to integrate some incident management flow, including the PagerDuty. For all the things we can create infrastructure, and we should create infrastructure with any IAC solution. And I would personally recommend Terraform. But let me mention one more thing because I think it's incredibly crucial. Terraform itself is quite mature, used in production. We use it for lots of different services. But CDK, it's still under our active development. So CDK, it's something what you may expect changes in because because it's in active development phase. I think it's obvious. Now it's in beta, so it's not alpha anymore, which is great. Still, they have this warning on their GitHub, so just remember about it. And yeah, everything what is generated, I mean, all the Terraform output, if it's generated, if it works for you, it's gonna work because after you run scenes, you already generated Terraform JSON file with you, which gonna work with the Terraform as previously, and that's the stable part. If it's okay for you, if you're ready to be to have some minor issues with CDK, you please adopt it with your projects. I found it super useful because I mean I really like power of the TypeScript. If you feel that you need more stable solution, stick with HashiCorp configuration language for now and then migrate partially or fully your infrastructure to the TypeScript. Okay, all code samples, all of them available in this repo. They cover a full talk. I tried to follow the same history and comments as we just did it during the presentation. Plus, there is one more repo which I'd like to share with you, Terraform TypeScript Frontend Infrastructure, which has slightly more advanced structuring. So you may use it as a reference too. Cool. Thank you so much. Again, my name is Denis. Hope you enjoyed and see you later.